lengthy two-chapter unit on polynomials, and we have to start with understanding the very basics. How do I simplify expressions with powers? So that's where we're headed to today. These are the rules of exponents. You've learned them in Algebra 1. We're going to go over them again. We first have to identify what a power expression is. A power expression has an expression could be a number raised to an exponent. It could be a variable raised to an exponent. It could be a coefficient times a variable raised to an exponent. It could be just a coefficient times a variable raised to an exponent, okay? All of these are power expressions. The base is the number that is going to be multiplied by itself, okay? So the 7 here, this is the base. The exponent is the small number that's raised up. That tells you how many times the base is being multiplied by itself, okay? You have to be careful with the base. You have to be careful in understanding what is actually getting the exponent and what is not, right? So one area of concern for students that they often mess up is the difference between -7 in parentheses cubed versus a -7 out in front, or negative out in front of 7 cubed, which is this one here. This first example is saying this, -1 times 7, and that whole thing cubed. So you cube the -1, you cube the 7. This example is saying this -1 is out in front and not getting the exponent at all. This is -1 times 7 cubed. Okay. If you're asked to evaluate says get it down to a final number. So our final number would be 7 times 7 times 7, and that is 343. This would be the evaluation, or the value. All right, so on a couple of these examples, what we're going to do is we are going to identify the base, the exponent, expand, and then evaluate, right? So on number 1 here, 3 to the 5th, my base is 3. My exponent is 5. If I expand, I'm going to go 3 times 3 times 3 times 3 times 3. And if I evaluate, I'm going to get 243. On number 2, my base is not just 3, but it's -3. -3 is the base. My exponent is 4. If I want to expand it, I have to use -3 4 times. Okay, and when I evaluate this, then I get positive 81. On number 3, what I have to do is this negative is out in front. I alluded to it on this last screen, the difference between these two. Here, first of all, rewrite this as -1 times 3 to the 4th. Remember, the base is the number or the variable that's actually receiving the exponent. This -1 is not. So my base is actually 3. My exponent, again, is 4. If I expand this, I have the -1 times 3 times 3 times 3 times 3. And watch, when I multiply this, I don't get 81, I get -81. And these two answers are very, very different. Okay, I'm going to do number 4 and let you do 5 and 6 as video questions. Here, our base is x. My exponent is 5. If I expand this, this is x times x times x times x times x. To evaluate, I'm going to plug in a -2, so I get -2 times -2 times -2 times -2 times -2, and that gives me -32. That's my evaluation. Okay. Go ahead and do 5 and 6 on the video as part of the video questions and come back and check your work. All right, the base here is -x. My exponent is 2. If I expand it, I get -x times -x. And if I plug in, I get negative of -2. Watch all these negatives. This is crazy. Okay? This becomes +2, and this becomes +2, so I get 4. This answer is 4. This is -1 times x squared. Different than this one. My base is x. My exponent is 2. If I expand this, I have -1 times x times x. If I evaluate this, I get -1 times -2 times -2. This answer is -4. Okay? All right, so one of our first rules is what we call the product of powers. I think of it as how do I multiply like bases, okay? So this only works when your bases are alike. You can only simplify this way when your bases are alike, okay? Like bases. The concept stems from the multiplication from the expansion. If I wanted to multiply 3 to the 5th times 3 squared, if I expanded 3 to the 5th, this is 3 to the 5th expanded, I would have 3 times 3 times 3 times 3 times 3, correct? If I would expand 3 squared, I would have 3 times 3. Now, based on our definition of a power expression, these are all just being multiplied together. So this is the same as 3 to the 1, 2, 3, 4, 5, 6, 7, 3 to the 7th. But it would be hard to do this if we had 3 to the 50th and times 3 to the 20th. That would be hard to expand everything. So there's a faster way. And when you are multiplying like bases, you are allowed to add their exponents. So 3 to the 5th times 3 squared equals 3 to the 5 plus 2. And I write it like this to help me remember the rule, equals 3 to the 7th, and we get the same answer. This way is just a whole lot faster. All right, so x cubed times x squared, whenever they're just being butted up and there's no multiplication symbol in there, it still means multiplication, all right? So this would be x to the 3 plus 2, and that equals x to the 5th. When you are multiplying more complicated monomials, all right, it helps in the beginning if you group your like bases together. So if you notice here, this is -1 times 4 squared, all right? And then I have x, a base x here and a base x here, a base y here and a base y here, and then just a base z right here, okay? So if you need to, go ahead and group things together. So I have, because that's the commutative property of multiplication, I have -1, and then I have times 4 squared, and then times 4. And then I have x to the 4th times x cubed. Then I have times y times y squared, and then times z. All right, so here's a like base and here's a like base. So I have -1 times 4 to the 2 plus 1, x to the 4 plus 3, y to the 1 plus 2, and then z. So I have -1 times 4 cubed, x to the 7th, y cubed, z. This is 4 cubed is 64. So that's negative 1 times 64. So that's negative 64, x to the 7th, y cubed, z. So go ahead and answer the video question and come back for the next slide. Remember that the simplifying rule is for each unique base, you keep that base and add the exponents together. So I don't say, like, because I have an x here and an x here, I don't have two of them. I have x to the 4th times x cubed. So that's just x to the 4 plus 3, or x to the 7th. All right, the next rule we're going to talk about is called the quotient of powers. I like to think of it as, how do I correctly simplify dividing like bases? Well, this concept has its roots in expansion of a power expression and the idea of canceling. If I wanted to simplify 3 to the 5th divided by 3 squared, I could expand my numerator, 3 times 3 times 3 times 3 times 3. I don't have to have all those parentheses. You can have it or you cannot. And then my denominator would be expanded 3 times 3. Now, every time I have the same value in the numerator or the denominator, they cancel to 1, right? So those cancel to 1, and these cancel to 1. And then I'm left with 3 cubed, which is equal to 27. Okay? There's a faster way. Notice what we're doing is we're kind of subtracting off the 2 in the bottom. The canceling process allows us to deduct those in our final answer. So what I can do is I can go 3 to the 5 minus 2. Now here's where students make mistakes. You have to take the exponent in the numerator and subtract off the exponent in the denominator. That's the only way it works. And be careful when you're subtracting off a negative number. We're going to get to that too. And so we get the exact same value. But this way is a whole lot faster. All right? So let's try these. I have x to the 33 power divided by x squared. Oops. So I'm going to go x. What? I've started over 15 times. I'm not doing it again. I have x to the 33 minus 2. So that's x to the 31st power. Okay, you just subtract those exponents, right? Now, with more complicated monomials, go base by base, do your subtraction, and then simplify our, well, in this case, that'll be all you need to do. All right, so remember, this is negative 1 times 4 squared, right? So I still have a negative 1, and then 4 squared divided by 4, well, that's just 4 to the 2 minus 1. One of them cancels, that's a minus. Okay. And then x to the 4 minus 4. And then y to the 6 minus 2. And z, oops, z, I need to erase this. Let me try again, get it in there to fit. So I have negative 1 times 4 to the 2 minus 1, x to the 4 minus 4, and then y to the 6 minus 2, z to the 5 minus 1. So here's what I get. Negative 1 times 4 is negative 4, x to the 0, y to the fourth and z to the fourth. Okay, so look back up here. X to the fourth divided by x to the fourth. If we would expand those out, we would have 4x's on the top and 4x's on the bottom, right? All of those would cancel. So that just becomes 1. So that's why, and we're going to learn this on the next slide or two, that anytime you have a non-zero base raised to a power of 0, it simplifies to 1. So this becomes negative 4 y to the fourth z to the fourth. Okay? Okay, so now we're going to talk about how to correctly handle negative exponents. And this is just a matter of moving them to the other level. If you think of the numerator as a level and the denominator as a level, if there's a negative exponent in one of those levels, then you move it to the other level and make the sign positive, okay? Now, when you get more complicated ones, that's where you want to approach step 1 first, and you want to simplify and get each base represented once raised to a power, okay, before you start moving around. Otherwise, you're prone to make mistakes. So combine any like bases, either using the multiplication rule or the division rule, and then move any negative exponents, take the base, move it to the other level, and change the sign of the exponent. So I have 1 over 3 to the negative 2. All right, so that means this is in the denominator, so I'm going to move it up to the numerator, 3, and I'm going to change the sign of the exponent to the positive 2. And I'm done. That's the same as 3 squared. 3 to the negative 3. This is in the numerator. This is like over 1, right? So I'm going to move it to the other level. I'm going to make a reciprocal. And then I'm going to change the sign of the exponent. Notice that I'm not changing the sign of the base. So I have 1 over 3 to the positive 3. Okay, so you remember I said combine like bases when needed? Here's an example of combining like bases where I need to. So first of all, I'm going to add those together. So x to the negative 7 plus 2 gives me x to the negative 5. Now, I can't have a negative exponent, so that means I have to move it to the other level, put it in the denominator, and change the sign of the exponent to positive. Right? This is number 4. I'm going to combine my like bases. So I have 3 to the negative 5th, x to the 1 minus a negative 3. Remember when I said be careful when you're subtracting off negative numbers? 1 minus negative 3. That actually goes positive, right? So this is 3 to the negative 5th, x to the 4th. This needs to be moved to the other level. So that's 3 to the 5th, and this is x to the 4th. Okay. There we go. X to the 4th over 3 to the 5th. Now we're going to talk about that zero exponent. I alluded to it before. Basically, the nugget of truth is any non-zero base raised to a zero exponent is going to simplify to the number 1. The base goes away, the exponent goes away, and you're just left with number 1. And the reason is if I did this, this is 3 to the 1st over 3 to the 1st. The division property says I can subtract my exponents. 1 minus 1. That's 3 to the 0. But we already know that 3 divided by 3 is what? 1. So any non-zero base raised to a zero exponent has to be the number 1. Okay? So let's look at this one. This 2 here doesn't have a zero exponent. So I still have the 2. X to the 0 power is a 1. Y to the 0 power is a 1. Z to the 0 power is a 1. So what's 2 times 1 times 1 times 1? 2. Right? Number 3, x, that's raised to the first power. So this is x to the first, y to the 0. What is y to the 0? That's 1. So I'm just left with x to the first, or x. Notice how I keep saying a non-zero base. What's my base here? My base is 0. So anything times 0 is 0. So this answer is still 0. Okay, we're going to work in our booklet. So if you have your booklet home, I would start working on some of these, and then we will work on them in class. There looks like a lot of problems, but they're very fast. So don't be concerned about time, but do some of them now if you have it home with you. Thanks for listening.